Hey, what's going on, guys? Let's do this problem right here. So we have the question that is asking which has the lowest vapor pressure. To determine the vapor pressure, we have to look at the intermolecular forces. So whichever has the highest intermolecular forces going to have the lowest vapor pressure. So we can mention that one right here. High, highest intermolecular force is going to have the lowest vapor pressure. So, and always whenever we have something with hydrogen bonding, that one is going to have the highest intermolecular force, right? So here we have to look at which one has hydrogen bonding, and if you look at this one, the first one has hydrogen bonding, because if you see, the oxygen is combined with the hydrogen, so this is going to be definitely going to have the highest intermolecular force. So if this one has highest intermolecular force, this one is going to have the lowest vapor pressure. So this is lowest vapor pressure, lowest vapor. And let's look at the next one, and we have CHF3 and CF4, and you can look at this CHF3 and say hydrogen bond with fluorine, there's a hydrogen bond exists, right? But it's not true. If you draw the diagram for this one, you will see that hydrogen is not directly connected with the fluorine. It's all of them are connected with the carbon. So if you draw the diagram, you will get carbon bonded with hydrogen and three fluorines like this, right? So there's no hydrogen bonding, so we can't determine with hydrogen bonding. But let's draw the diagram of this CFO and see what happens. So if you draw the diagram CFO, you will see this is a symmetrical, right? All the four atoms are same, therefore this is a symmetrical compound. So if it's symmetrical, it's a non-polar molecule, therefore it only going to have London dispersion force. But if you look at this one right here, we have a hydrogen molecule, so this is not symmetrical, because all the four atom around this one is not same, therefore this is not symmetrical, and it doesn't have hydrogen bonding, but therefore it's going to be a dipole-dipole. So if it's dipole-dipole, dipole-dipole is stronger force than the London dispersion, so this is going to have the strongest force. So if it's strongest force, then we can say this is lowest vapor pressure. Lowest vapor. So strongest is the best word to describe the force. So instead of highest, I can say strongest. Strongest intermolecular force. So that's what determines the lowest vapor pressure. And let's look at the next one. We have C20H42 and C30H62. All of them are combined with carbon and hydrogen, so both of them are going to have London dispersion force. But let's see how we can determine the highest intermolecular force, strongest intermolecular force. If you look at the carbon number, it's 20 and here's 30. So whenever we have a compound that has more bonds and more atoms, more complex form, that's going to have the strongest intermolecular force and highest London dispersion forces. So therefore this one is going to have the highest intermolecular force, therefore this is going to have the lowest vapor pressure. Vapor pressure, right? And let's look at this one right here, Br2 and I2. Br2, I2, both of them are linear shape, so both of them are non-polar, so they only have London dispersion force. But to determine which one has the lowest vapor pressure, we have to look at another way, like the molecule weight. If you look at the molar mass of this one, I2 is going to be higher than the Br2. Therefore, whenever we have the highest molecular weight, that's going to have the strongest bond, and therefore we can say this is I2 has the lowest vapor pressure. Lowest vapor pressure, and that's how we determine the lowest vapor pressure of the molecules. I hope you guys liked this video. See you next time.